All right, so our goal is to solve for x. Our problem is that there's an x on this side and an x on this side. We have to move them over, get them on the same side, and then we have to get x by itself, and then we have to solve it. So what I'm going to do is leave this x alone. I'm going to start trying to do things in my head, and I want you guys to think it through. What happens if I take this this x to the radical 3, and I move it over here? What happens to it? It becomes a negative. So I have my x. I'm going to move this one over, and it becomes negative x radical 3. And then what happens to this negative 4 when I move it to the other side? Positive 4. If you don't see that, then you can actually write it out. Minus x to the radical 3, or else plus 4 on both sides. Because now we'll have x's on the same side. We're trying to solve for x, but whenever you have an x on both sides of the equation, you have to move one of them over. So what we need to do now is get x alone, and to do that, in this particular case, not in all cases, these two have an x in common. This has an x and this has an x. So x goes out in front like a GCF. And if you divide by x here, what do you get? No, you divide by x, you're left with 1. Let me do that in red. You're dividing by x. And if you divide by x right here, what are you left with? Negative radical 3. Good. Equals 4. Now there's only one step left to get x by itself. You need x. So what you have to divide by is the parentheses. Divide by the 1 minus radical 3. Divide by 1 minus radical 3. So that these two things can cancel. Your entire goal this time is to get x by itself. We're no longer just simplifying. This time we're solving. But in this case, you're not allowed to have radical 3 in the bottom. So we have to do one more thing. Do you remember what you do to make this whole thing go away? Good. Everything's the same except for the sign. You go with the opposite sign. You multiply it by 1 plus radical 3. It's called rationalizing the denominator. You do 1 plus radical 3. So what we're left with is 4 times 1 is just 4. And then we're left with 4 times radical 3. Bless you. All right, now here's the thing to be careful about. When you do it this way, you square both numbers. 1 squared is 1. You always make it minus. But what do you get when you square radical 3 times radical 3? You do not get 9. What do you get? 3. Good, because the house goes away. So what we're left with is 4 plus 4 radical 3 over 1 minus 3 is negative 2. And we have to see if we can reduce. You can only reduce if it's all or nothing. When there's a plus sign or a minus sign, it has to be all or nothing. Is there a number that can go into 4, 4, and negative 2? Negative 2. Good. So you have to reduce them all. Divide by negative 2, you get negative 2. Divide by negative 2, you get negative 2. Divide by negative 2, you get 1. Your goal is to get 1 on the bottom if you can. They don't like to leave negatives on the bottom, especially when you get into trig. In higher classes, they won't want you to leave a negative sign on the bottom like that. All right, last step. We're left with negative 2 minus 2 radical 3 over 1, but I'm not going to write that because over 1 just makes something stay the same. It's the same thing you've done in the past, except they threw radical signs in at you. So you've got to be careful about that. This is getting close to like the quadratic formula type of thing that you've done in the past. Question on that one? I see that most of you don't have room to do letter B, so let's try letter C. Leave letter B alone. Maybe we'll do that as an extra practice. It's a good problem, but most of you don't have room for it. So try letter C here. Our goal is to get A by itself. What's our problem?
You have to move it.
Yeah, the A is on both sides. It's only supposed to be on one side. Move the one that's easier. Which one would be easier? Yeah, because then we would have a positive number left over right there. So do minus a radical 3 on both sides, minus a radical 3, and you will have 2 equals, how many a radical 3's are there? 1. A radical 3, and then it's plus 7. Every problem is going to be different. Your goal is to get the a by itself, and you have to deal with the radicals to make that happen. What do you think you do next? Good. Just subtract the 7. Gives you negative 3. Oh, sorry. I wrote down my result instead of writing down what I was doing. Minus 5 equals a radical 3. What do I have to do to get a by itself? Yeah. And this one's going to be easier. There's no plus or minus that you have to deal with. It's just dividing by radical 3. Some of you probably already see a shortcut that can happen every time. But if I don't want radical 3 on the bottom, what do I do to the top and the bottom? What do I do to both of them?
Multiply
By?
3.
Good. Multiply by the radical 3 so that the house will go away, but the 3 will stay there. So we end up with, on top is negative 5 times radical 3. And on the bottom is just 3. That's what your answer would look like. There's no plus, so you don't have to do the opposite sign. You only have to do that when the bottom has something plus a radical or minus radical. Reduce if you can, but nothing can reduce. Questions? All right. These next two, I'm going to go through kind of slowly, just make sure you've got the idea. But the thing is, sometimes you can get an answer that doesn't actually work. Fill that in. That's called extraneous.